Hi everyone, this is a tutorial giving you a quick description on how to use our software for calculating uncertainty on paleomagnetic directions, specifically when, for example, you want to compare site mean directions, combine site mean directions or combine paleomagnetic poles. How can you do that taking into consideration their uncertainty and propagation of that uncertainty? So there's a number of ways that you can do this. If you're familiar with Python and Jupyter, you may want to simply install the package and run the included Jupyter notebook, which is available on GitHub following this link. If you're less familiar with that and you don't have that much data to process, then you may simply want to use the interactive Jupyter notebook, which is provided free on Binder, which is a free cloud service. It'll allow you to do the calculations, you can record your results, and there's nothing to install. So we're going to look at the Binder version here, and to launch an instance on the cloud, we simply click the Launch Binder option. This takes us off to Binder. It takes a little bit of time to start up the notebook. It shouldn't take too long. If you're interested in how the launching of the instance of the software is going, you can always click on the Show button here, which will give you an update. It says Launching Server. Depending on how busy the Binder cloud is, this may take a few minutes. It may be very quick. But what you'll see once it starts is a Jupyter notebook that you can effectively interact with, that's hosted on the cloud, so there's nothing to install and it's very simple to use. We get a little cog showing that we're close, and what we have now is our interactive Jupyter notebook for site and pole directional uncertainty. Now, even if you're not familiar with Python or Jupyter notebooks, this has been written in a way that it's very interactive, so you simply need to put your data into a table and press process, and it will provide you with the result. So the data that we're dealing with are either site mean directions, for example, where you have a declination, an inclination, the number of directions that went into the estimation of that mean, and an alpha 95, or similarly, if you're talking about pole positions as well, the same information. So here's the table where we input our data. These are the parameters that we need to input in the different columns A, B, C, and D. And each observation should go into one row. So I'm just going to imagine, for simplicity and quickness, that I've got three site mean directions that I want to combine and estimate their propagated uncertainty on the average direction. So to begin with, by default, I've just got one row, so I'm going to add in a couple of extra rows for those directions. If you hit the add row button too many times, you can always hit the remove row and that will take it out. So what I need to do now is define the declination, inclination, number of data points, and alpha 95 of my first site mean direction. Now I'm just going to make these numbers up for simplicity. So maybe the first declination is 80 degrees, my inclination is 45 degrees, the number of directions or specimen directions that went into that site mean estimate, maybe that was 6, and there's an alpha 95 of say 5.1 degrees. So that's my first site mean direction defined, and of course equivalently you could do this with poles if you wanted to process poles. So let's put in my second one, maybe that's 72, inclination of 40, and maybe that's relatively small, we could say just 3 directions on that site mean, and maybe an alpha 95 of 7, and then the last one, and again just to emphasize, I'm just making these numbers up to be quick, maybe this is 65, an inclination of 47, maybe n for this one's quite large, say 8, and an alpha 95 of maybe 3 degrees. Now once that information's input and it's all accepted in the table, we can simply go down to Process Data, hit the button, and it will do the calculation. So this is the calculations of the mean inclination, mean declination, and alpha 95 when we incorporate uncertainty, so when we do our uncertainty propagation, and without uncertainty that corresponds to the traditional calculation where everything's considered to be a unit vector direction, the average inclination, declination, and the alpha 95. So this is output here. It's important to say that's not saved anywhere on the cloud. It's not saved to an output file on your computer. So the simplest thing to do if you're using the cloud version is write the result down, okay? Because it isn't going to be saved on your computer anywhere. Now, if you realize you've made a mistake, it's very simple to just modify the data and reprocess the result. So, for example, if you typed in a lot of information, then you don't want to have to restart the process from the very beginning. So maybe actually the alpha 95 on this final sample wasn't 3, maybe it was much larger, it was actually 13. So we can just change that value, put it in as 13, process data. Now the way that we've done this, it doesn't overwrite the existing results, but it will simply print them underneath. Okay, so you've now got your new result for your adjusted data up here. So any mistakes can be very quickly corrected and the data reprocessed. As I said, these numbers aren't saved anywhere on the cloud or on your system, so you'll need to write them down. Also, because this is a free cloud service, your connection to the cloud may be cut if you're not interacting with the workbook for, say, 5 minutes or so. So once you're ready to start inputting data, I would suggest you do it all in one go and process the result. Don't type half the data in and then go and get a cup of coffee, because your link to the free server will actually be broken. Once you close the tab in your browser, again, your link to the cloud will be broken. Now, if you've got any questions about the binder version or running this locally, or you'd like to report a bug, then please just email me on my ANU email address, and I'll address those problems. So thanks for listening, and that's the end of the tutorial.